Imagine an autonomous AI agent, detecting a GPU hardware fault on its own cluster.
Yeah, pulling the diagnostic logs and actually initiating a remediation sequence.
Right, all without human intervention.
Yeah.
And that is not a white paper concept anymore.
No, it really isn't.
It's an operational reality as of this week. So welcome to our deep dive for Saturday, June 6, 2026. If you are building, managing, or securing AWS infrastructure, you know that keeping up with the deployment velocity can basically be a full-time job.
Oh, absolutely. I mean, between May 31 and June 05 alone, AWS dropped 53 distinct updates.
53. It's
Yeah.
wild. But our mission today isn't just to read you a changelog.
Right. Nobody wants that. Our goal is to extract the actual architectural signals from all that noise.
Exactly, because when you look at the sheer volume of deployments this week, a massive structural shift becomes undeniable across two main vectors.
Yep. First, generative AI agents are moving out of those ephemeral, stateless API wrappers and into persistent, heavily integrated execution environments.
And second, the underlying compute, networking, and database layers are undergoing this rapid scale-up to support the extreme durability and, well, low latency demands those agents require.
It's a huge shift. We are talking about deep terminal access, automated failovers, and fundamental changes to how we handle networking on bare metal.
Yeah, so let's start right at that AI execution layer, because the deprecation of those stateless prompt architectures is happening fast.
Extremely fast. And the Amazon Bedrock updates from this week highlight exactly what is replacing them.
Right, because AWS just announced general availability for OpenAI's GPT 5.5, GPT 5.4, and Codex on Bedrock.
Which is huge on its own. But significantly for government and, heavily regulated workloads, GPT 5.4 is immediately available in the AWS GovCloud US West region.
Wow. Okay, so those isolated compliant environments can now execute highly complex reasoning and coding tasks without data ever leaving Bedrock's secure queues.
Exactly. But I think the real structural change for developers is the redesigned Bedrock console, specifically optimized for the new Bedrock Mantle endpoint.
Ah, right. The Mantle endpoint. This is a crucial update.
It really is. The Mantle endpoint natively supports the OpenAI responses and chat completions APIs, as well as the Anthropic Messages API.
Which solves a massive headache for teams migrating workloads. I mean, if you have a code base heavily reliant on the OpenAI SDK, you don't have to rewrite your entire interaction layer to use Bedrock.
Nope. The console even auto-generates project-aware documentation where your SDK snippets are pre-filled with the correct model ID, region, and that Mantle endpoint URL.
That's so convenient. Plus, they added CloudWatch metrics exclusively for the AWS Bedrock Mantle namespace.
Right, giving you inference counts and token totals down to the specific project and model level.
Yeah, the visibility is great. But if we are looking for the update that fundamentally changes how AI operates in the cloud, I think it is inside the Bedrock AgentCore runtime.
Oh, without a doubt. AWS just launched the Invoke Agent Runtime Command Shell API.
Right.
And this isn't a standard API call. This initiates a persistent PTY-backed terminal directly into a running agent session over a WebSocket.
Wait, let me stop you there because we really need to unpack that.
Yeah.
When you say a PTY-backed terminal, we are talking about a pseudo terminal.
Exactly.
It is provisioning a full interactive Linux terminal experience inside an isolated micro VM.
Yep, it supports tab completion, standard interrupt signals, and automatic reconnections for coding agents like Claude Code or Codex.
But let's look at the operational impact here. With Bedrock AgentCore now supporting persistent interactive shells, how does maintaining state across a single session fundamentally change the debugging process for developers running autonomous coding agents compared to the previous one-shot asynchronous executions?
I mean, it changes everything about the debugging loop. Previously, using the standard Invoke Runtime Command API, every execution was a one-shot asynchronous event.
Right, totally stateless.
Exactly. Every single time you invoked the agent, you had to reestablish the context, repass the environment variables, and reset the directory state. It was incredibly inefficient for complex troubleshooting.
Yeah, I can imagine.
But with this new interactive shell, your state is preserved across commands within the exact same session. Your working directory, your command history, your loaded variables, they all remain intact.
So if my local machine drops a connection, what happens to the agent?
That is the beauty of it. When you disconnect and reconnect by passing the runtime session ID and the shell ID, you land in the exact same micro VM state.
Oh, wow.
Furthermore, a single agent runtime now supports up to 10 concurrent shells.
10.
Yeah, 10. You can have multiple developers or even multiple automated diagnostic scripts debugging different branches within the same environment in parallel.
That is incredibly powerful. And, to secure an environment that powerful, AWS also updated Bedrock Agent Core identity.
Right, the bring your own secrets update.
Exactly. It now supports a bring your own secrets model via AWS Secrets Manager, because previously, Agent Core forced you to use service-managed secrets.
Which was a major blocker for enterprise teams.
Yeah, it restricted the use of customer-managed KMS keys, custom tagging, and bespoke rotation policies. Now, you define your secret in Secrets Manager with your own governance, and just reference the secret ARN in the Agent Core credential provider.
And we are seeing the orchestration of these agents integrate directly into standard enterprise tooling, too. AWS Step Functions now natively integrates with the Agent Core managed harness.
So you can visually map out an agentic reasoning step right inside your workflow.
Yep. You define the model, the system prompt, and the specific tools for that invocation, and Step Functions handles the execution. The execution history even gives you direct links to the granular agent turn details inside CloudWatch.
Speaking of tooling, the AWS Model Context Protocol, or MCP Server, got a massive capability boost.
Oh yeah, the cross-account access.
Right. It now supports cross-account and cross-role access within a single session. This means an AI agent can specify a different IAM profile on a per-command basis.
And the operational efficiency gain there really cannot be overstated. Think about a standard deployment pipeline. An agent can query CloudWatch logs in your production account, analyze the error, and then immediately update an S3 bucket policy in your staging account.
Sequentially.
Right, sequentially, without ever restarting the MCP server or swapping out local credentials.
That's so smooth. And for teams running highly secure environments, Amazon Q now supports VPC connectivity for privately hosted MCP servers.
Yep. Whether you deploy those servers on EC2, Fargate, or inside Agent Core in a private subnet, Q will route the natural language interactions securely through your VPC. No internet gateways required.
We're also seeing SageMaker inject some serious business context into these workflows. The SageMaker data agent now integrates directly with enterprise catalogs like Calibra, Atlan, and Elation.
So if a business user asks an agent to query a metric like monthly recurring revenue, the data agent uses metadata glossaries to map that business term directly to the technical table names.
Which bridges a huge gap. It even maintains conversation history across notebook sessions now, so analysts don't lose their context when stepping away from a complex SQL or Python task.
Right. And for the data science teams orchestrating those tasks, SageMaker Unified Studio introduced notebook scheduling via the notebook operator.
Okay, what does that enable?
It allows you to chain parameterized notebooks together on dedicated compute, meaning the output data of your extraction notebook automatically serves as the input for your training notebook.
Oh, got it.
And security teams will appreciate that Unified Studio now enforces custom IAM permissions boundaries for service control policy compliance right at the blueprint level.
Nice. Setup times for Unified Studio have also dropped to under 20 seconds with automatic model customization permissions, and it rolled out in 12 languages.
Yeah.
But to bring this AI segment home, SageMaker AI launched serverless multi-turn reinforcement learning for agent model customization.
This is critical. It manages the entire complex training loop, the rollout orchestration, trajectory collection, and checkpoint management.
Right, because instead of rewarding a model for a single correct answer, it evaluates and rewards the full sequence of decisions an agent makes, which is just absolutely critical for fine-tuning autonomous models like Quinn 3.6 or Gemma 3D1B.
Which brings us to the physical layer.
Yep.
Because those multi-turn reinforcement learning loops require massive compute power, the agents are getting smarter, they need bare metal to run on, and the network architecture is adapting to handle it.
Yeah, and you mentioned the hook at the start of our deep dive agents debugging hardware.
Right. Amazon SageMaker HyperPod just introduced open source troubleshooting skills via AWS Systems Manager.
This blew my mind.
I know. These encode diagnostic workflows for things like GPU hardware faults or NCCL communication failures directly into the agent.
So the agent can extract the specific logs from the cluster node and actually suggest or even execute the remediation.
Exactly.
But what I find even more fascinating mechanically is what HyperPod is doing with the network interfaces. SageMaker HyperPod now supports EFA-only network interfaces for cluster instance groups.
Right, the Elastic Fabric Adapter.
Yes, which is built for high-throughput, low-latency internode communication. And the ENA, the Elastic Network Adapter, handles your standard IP routing.
Yep.
So if SageMaker HyperPod's EFA-only interfaces drop the ENA device completely. How does the node handle standard IP routing for basic control plane tasks without triggering IP address exhaustion in the subnet?
That is a very critical network engineering question. The node doesn't drop IP routing entirely, it actually separates the planes.
Okay, how so?
The primary network interface on the bare metal node retains the standard ENA for basic IP routing back to the AWS control plane. The EFA-only designation applies strictly to the secondary interfaces.
Ah, I see.
Yeah, in massive distributed training clusters, nodes need to talk to each other constantly using the message passing interface, or MPI.
Right, and historically, every one of those secondary connections required both an EFA for the speed and an ENA for the IP, which consumed a VPC subnet IP address for every single interface.
Exactly, and when you scale to thousands of GPUs, you just drain your subnet's IP pool instantly. By specifying EFA only in the cluster parameters, the node allocates those secondary interfaces exclusively for that MPI traffic.
Wow.
It bypasses standard IP allocation entirely on the secondary channels. You get the massive throughput for your training loop without exhausting the IPv4 or IPv6 blocks in your VPC.
That is a brilliant architectural solve.
Mm-hmm.
Moving up to container orchestration, Amazon ECS managed instances now support AWS Trainium and Inferentia accelerators.
Yep, you just add Neuron Core all to your task definition, and ECS handles the accelerator allocation to a single task per instance.
And for standard compute, ECS with AWS Fargate just pushed its limits up to 32 vCPUs and 244 GB memory for both x86 and AR.
That's some serious density. And on the Kubernetes side, Amazon EKS and EKS distro updated to version 1.36. There are two critical updates here for platform engineers.
Let's hear them.
First, the promotion of user namespaces to general availability. This provides a deep security boundary by mapping the container's root user to an unprivileged user on the host node.
Meaning, if a process breaks out of the container, it has zero privileges on the underlying EC2 instance.
Exactly. That neutralizes an entire class of container breakout vulnerabilities. And the second update is just as impactful for operations. In-place, pod-level resources, vertical scaling.
Oh, I've been waiting for this.
Yeah, you no longer have to restart a pod and drop active connections just to increase its CPU or memory limits. The scheduler resizes the shared budget dynamically.
That's fantastic. EKS capabilities also added Amazon CloudWatch vended logs for managed controllers like Argo CD and Crow, giving you that operational visibility without incurring extra EKS charges.
And we saw significant physical hardware rollouts as well. EC2 launched the M8i and M8i Flex instances in the Asia-Pacific New Zealand region, utilizing Intel Xeon 6 processors to deliver a massive 2.5x increase in memory bandwidth.
That's a huge jump.
It is. And in Europe, Ireland, they deployed the M-ASIN instances. Those leverage the 5 GHz AMD EPYC Turin processors, pushing 4.3x higher memory bandwidth and up to 3x higher EBS throughput compared to previous generations.
Incredible. AWS Parallel Computing Service also released a production-ready deep learning AMI on Ubuntu 24.04, heavily optimized with pre-installed NVIDIA drivers, CADA toolkits, and Lustre clients integrated with Slurm.
But all of this compute power starves if it doesn't have a highly durable, low-latency data layer feeding it.
Exactly. Which brings us to the database and resiliency updates. Amazon Elasticache for Valkey introduced multi-AZ durability.
Yes, they implemented a multi-AZ transactional log supporting both synchronous and asynchronous writes.
And with synchronous writes, the data is persisted across at least 2 availability zones before the client ever gets a response, and they are doing this with single-digit millisecond latency.
Which is incredibly fast. That qualifies Elasticache for highly strict operational workloads, things like long-term memory for those AI agents we discussed, or payment tokenization where you absolutely cannot afford a single drop transaction during a node failure.
Totally. And for disaster recovery across broader architectures, the Application Recovery Controller, or ARC, expanded its region switch capabilities.
This is huge for automated failovers. ARC deployed 3 new execution blocks. One for Aurora serverless scaling, one for Aurora provision scaling, and one for Neptune global database failovers.
Because during an active incident, you just don't have time to run custom scripts to right-size your passive secondary clusters.
Exactly. These ARC blocks automate that scaling instantly when you trigger a failover.
Let's shift to the NoSQL domain, specifically Amazon Keyspaces for Apache Cassandra. They updated their change data capture, or CDC streams, to finally expose the CDC iterator position within the get records response.
Yes, they did.
And let me jump in on that Keyspaces update because the operational implications here are fascinating. By exposing the CDC iterator position, Does this explicitly allow developers to abandon continuous polling architectures in favor of adaptive polling? And what is the actual impact on read capacity consumption costs?
Yes, that is the exact architectural outcome. The response now returns an iterator position field that explicitly tells you if you are ATIP or behind tip.
Okay.
Before this, consumers had to execute continuous polling loops against the database, blindly checking for new data. Every check consumed a read capacity unit, or RCU,
Even if there was no new data.
even if it was empty. Now, you implement adaptive polling. When the iterator tells you it is 8-tip, your code knows there is no new data. You dynamically back off the polling frequency. You stop burning RCUs on empty reads, which leads to a direct and measurable reduction in your monthly key spaces bill.
It is a simple API addition with a massive financial impact. We also saw authorization centralized in the GovCloud regions, with S3 tables and Apache Iceberg materialized views now supporting AWS IAM-based authorization.
An Amazon OpenSearch service brought its modernized UI into GovCloud as well, dropping the Discover interface, which beautifully unifies log exploration across pipe processing language, SQL, and Lucene.
Plus, Amazon Q Research now supports customer-managed keys via AWS KMS for symmetric encryption.
On the developer integration front, databases are becoming much more accessible from front-end workflows. Amazon Aurora PostgreSQL, Aurora DSQL, and DynamoDB serverless are natively deployable right from the Vercel marketplace.
That's a great integration. For legacy and enterprise migrations, Amazon RDS for DB2 now supports version 12.1 and the DB2 Community Edition, which is excellent because it waives the commercial software licensing charges for your dev and test environments.
Such a cost saver. Amazon RDS for SQL Server also rolled out Bring Your Own Media via the Microsoft License Mobility Program, tying directly into AWS License Manager so you can easily track your core counts.
All right, moving to networking and security, AWS Direct Connect just deployed VIF rate limiters.
Oh, this is a big deal for network admins.
Yep. If you manage dedicated connections, you know the pain of noisy neighbor congestion where one workload saturates the pipe. Now you can configure bandwidth maximums for up to 10 virtual interfaces on a connection, dialing it in from 50 mPs all the way up to 1.6 TBPs.
And it actively drops excess ingress and egress packets to enforce the limit and publishes the utilization metrics straight to CloudWatch.
Security and identity management saw crucial hardening too. Amazon Cognito launched near real-time multi-region replication,
which constantly synchronizes your user pool configurations, credentials, and federation setups to a standby region. If your primary region goes down, your users experience uninterrupted sign-ins.
Also, Amazon Inspector completely overhauled its architecture by releasing the Inspector VM scanner for EC2.
Yep.
This replaces the old agent-based scanning engine, right?
Exactly. It shifts to an agentless model using EBS snapshots to evaluate the instance. It expands vulnerability detection to things like WordPress, Python packages, and Ruby gems, while simultaneously dropping the baseline CPU utilization on the target instance because there is no heavy scanning agent running in the background.
That is a huge win for performance. AWS Config also expanded its governance, adding 9 new resource types for Bedrock and SageMaker and introducing internal service-linked rules.
Right. This allows services like Security Hub to execute managed config rules for evaluations without charging the customer for the config evaluation overhead.
Visibility into billing and operations got sharper too. Cost and Usage Report 2.0 now natively integrates with Athena and Redshift,
which means you don't need to build custom ETL pipelines anymore. CRR 2.0 just exports the data in CARK or gzip formats and automatically deploys the table definitions so you can query your billing data instantly.
AWS Compute Optimizer also extended its lookback period from 14 to 32 days for EBS and ECS recommendations.
That 32-day window is critical because it finally allows the engine to analyze month-end processing spikes before making right-sizing recommendations.
That makes total sense. In the IoT space, AWS IoT Core added ping and connection.authner log event types, giving engineers visibility into MQTT keep-alive failures and certificate rejections.
And AWS IoT Device Management also updated its connectivity API to retain MQTT session metadata indefinitely, whereas IoT Core drops connection details after 30 minutes.
We should also note Amazon MQ for RabbitMQ is now running on Graviton 3 instances in the AWS European Sovereign Cloud in Germany.
Yep.
Let's talk about email infrastructure because Amazon SCS introduced tenant-level suppression lists.
This is a massive update for multi-tenant architectures.
Yeah. With SES introducing tenant-level suppression lists, does this eliminate the need for SaaS providers to build custom middleware to isolate bounce rates across different enterprise clients on the same AWS account?
It explicitly eliminates that requirement. Previously, if one of your tenants triggered a hard bounce, an account-level suppression list would block your other tenants from ever emailing that address.
Right.
SaaS platforms had to engineer highly complex routing logic to prevent that cross-contamination. Now, SES lets you define the suppression scope as tenant.
Oh, nice.
Yeah, it isolates bounces and complaints strictly to the specific tenant name parameter you pass during the send. It handles the multi-tenant isolation natively at the AWS service layer.
That removes a huge operational burden for SaaS platforms. Wrapping up with specialized industry operations, AWS Deadline Cloud now supports persistent EBS storage for service-managed fleets.
Which is fantastic for visual effects studios because it preserves Conda environments and shader caches across worker lifecycles.
It also added a plugin sync feature that automatically pulls studio plugins from an S3 bucket right into the cloud worker at startup.
In life sciences, AWS HealthAllMix updated to Nextflow version 26.04, bringing in the strict syntax parser. They also deployed Nextflow version pinning at runtime.
So using the engine settings parameter, researchers can test new workflow engine versions without having to modify their underlying source code.
Exactly. Amazon Location Service deployed robust public transit and intermodal routing APIs, calculating complex park and ride combinations.
And finally, Amazon Connect massively expanded its workforce management capacity. A single schedule can now support up to 5,000 agents.
The engine intelligently optimizes the placement of ad hoc activities, calculating the minimal service level impact when you need to schedule compliance training or meetings.
Plus, they added EventBridge integration to instantly notify agents when their shifts or leave requests change.
When you look at the aggregate volume of these 53 updates, the trajectory is very clear.
Yeah, AWS is giving generative AI agents deeper, persistent access to the execution layer while simultaneously hardening the bare metal compute and database architectures to ensure those workloads never fail.
Exactly. The transition from stateless functions to micro-VM-backed persistent shells running autonomous loops fundamentally alters the engineering landscape.
It really does. And as you review your own architectures this week, I want you to consider the implications of what we've covered. As AI agents gain persistent terminal access and infrastructure features like ARC failovers and Valky multi-easy durability automate complex scaling events, are we rapidly approaching a threshold where the cloud is largely self-healing and self-orchestrating?
It's a profound question.
Right. If an AI agent can use a hyperpod troubleshooting skill to diagnose and debug its own hardware node, how does the daily role of the traditional DevOps or platform engineer permanently change in the next 12 to 18 months? It's something to think about.
Absolutely.
Thank you for joining this technical deep dive. See you next week.